and gentlemen, we have now the problem number 2 around my lines. It is problem number 2. We have some point is given, and another line is also given. So are given the point the line passed through this point A, and another line, and in this case it is video number 2. My line is a parallel to my previous line. Parallel. That's the problem around it. We will take another example, video number 3, with orthogonal or perpendicular, and here is a parallel. So what's about parallel? If I have two lines like this, g of x, let's say, equals mx plus c, and even another line y of x, for example, with let's say r times x plus t. We have a gradient of those lines. Here is a m, and here's a gradient r. And if I stand that my lines are parallel like this, g of x is parallel to y of x, then follow to the idea my gradients are the same, m equals r. M is equals R. This very, very important thing and idea around many problems of lines. Even other problems, like problems at your study, maybe for university. It's very popular problem, I would say. Okay, let us say I have a line like this: y equals 2x plus something, like let's say 100. Okay, and I would like to write down another line, for example g of x, with the idea parallel to y, followed by the same term 2x I have take now, plus another number, I don't know which one, but it is a b. The idea is behind that the slope or gradient is the same here. Okay, so it's the idea behind it. And now following 1, 2, 3 examples. Okay, like this. Example number 1. My line passed through the point A with 2 and 3. So line pass through the point A, and also my line is a parallel to another line, maybe g of x equals 2x and minus 12. I start my calculation with the idea the lines are parallel, and I can already say, or I can already stand that my previous line y is equals also 2x plus or even minus something what I don't know yet, something like here. But here we have a c, it's unknown c, still unknown. Because of video 1 we have had the formula for c equals y minus gradient m times x. It was the formula number 1. Okay, now I have everything for my c, excuse me. I have y, I make it clear with my colors, it is y, because passing through the point 2 and 3. Even I have x, it is a x, it is 2. And now also is my slope or gradient known, it is 2. Okay, so it's easy thing, I hope so. Again, I marked for you the colors corresponding to my numbers for calculating. Y was blue, my favorite color, blue, but not violet. Okay, so idea is clear. Now we're calculating this C. This C is unknown now, no problem. C equals, C is equals, Y is 3 minus M, it is gradient 2, times X is 2. 3 minus 4 leads to minus 1. So my C is minus 1. And if I have minus 1, I can put my minus 1 here. It is my result. 2x minus 1 is my line. Passing through the point 2 and 3 and also parallel to the given line 2x minus 12. On this here, I would like you to show my control, my check, my control here. I would like to know, is it possible if I put here to the x this value of 2? I write down y of 2 equals 2 times 2 is 4, and then minus 1 leads to 3. Exactly, it is a 3. It is my point. This line through for real, pass for real through this point 2 and 3. So if it's clear, I give you one or even two examples for self-working like this, like I've done always. Another point is given 1 and 3, and it should be parallel. My line y should be parallel to the line G with minus 3x minus 15. I would like you to notice this example. My answer here would be y is equal minus 3x plus 6. It is my answer for you for later. And even another example. My line passed through the point minus 2 and 6, and my line y is parallel to G given by 2x plus 6. My result here would be y equals 2x plus 10. So, thank you very much indeed.